Okay. Afternoon, everybody. Just let me know if you all are hearing me. All right. Okay, so you all are hearing me, right? So in the last two sessions, we were looking at functions, right? And we went through different types of functions. What we're going to look at today is something called a linear function, all right? So the first thing that I need you all to know or understand is what is called a Cartesian plane, right? Now you all would have done this throughout the years. Basically, in a Cartesian plane, or when we draw a graph, we have what we call the x-axis, which is here. That's the horizontal axis. And we also have something called the y-axis, right? So there are two axes in the Cartesian plane, right? Now, any point on the Cartesian plane, we usually represent it using two values. We have an x value and we have a y value, right? So for example, this point here, let's say this point is A, right? And I were to write the coordinates of the point A. So the coordinates of A is going to have an x value and a y value. So the x value, to determine the x value, we need to come down here, right? And that is 1. And we need to go across to the y-axis, that's here. And this here is 3, right? So any point on the Cartesian plane can be represented by two coordinates, an x coordinate and a y coordinate, okay? Now let me ask you a question. What is the coordinates of the point B? Right? What are the coordinates of the point B? Right? Let me see what you all give me. All right, so I'm seeing 4, 5 as one answer. So to know the coordinates of B, essentially what we need to do, we need to look at what the x value is. So we're going to come down here. So that value is 4, right? And then we need to go across to my y-axis. That's this value here. So therefore the coordinates of the point B are 4 and 5, right? Now let's try a different one. Let's try this one here. All right, try the ones that give students some trouble. So this is the point C. I want you all to tell me what the coordinates of the point C are. So Sharice is saying 3 minus 2. Is that correct? Let's see. So we need to go to my x-axis. That's where we're going up here. Right? And we can see that that point is 3. And then we need to go across here to my y-axis. And this point here is minus 2. Right? So that's the coordinates of C. The coordinates of C is 3 minus 2. Now I know this might seem a bit trivial, however, I've seen students get lots of trouble with these questions. Just to plot a point they're having problems with. So what about this point here, point D? What are the coordinates of the point D? So I'm seeing some answers here, minus 5, 4. Let's check that. So first thing we do, we always write the x coordinate first. So we're going down to the x-axis, right? So you're coming down here, and this point is minus 5. And we go across to the y-axis, and this point here is 4. All right? So this is basically how we identify points on a Cartesian plane. All right? Now, this topic we're talking about here is trying to graph linear functions, right? Now, let's look at something here. We have a Cartesian plane here, and we have a straight line. That's a red line that we are seeing here, right? That straight line, right, has an equation, and that equation is given by x is equal to 2, right? Every time you have a vertical line, the equation of that vertical line will always be x is equal to something, right? So if we look at something here, that line passes through the point x equal 2. So the equation of this line is x is equal to 2, right? Now, let's look at the next one here. Again, I have a vertical line, right? And that vertical line passes through the point minus 4. So can somebody tell me what is the equation of that red line there? Alright, so I see a lot of answers coming in here. X is equal to minus 4. That is great. Alright, so the equation of this line here, that vertical line, is x is equal to minus 4, right? So the equation of any vertical line is always going to be x is equal to something, right? Now let's look at this line here now. This line is a horizontal line, right? The red line is a horizontal line, but the red line passes through the point y equal 3. So the thing is, this equation here, the equation for this line is y is equal to 3, right? That is the equation of this horizontal line. It's y equal to 3, right? So what about this one now? Can somebody tell me what the equation of this line is? Right, so I'm seeing y equal minus 1. That is correct because the line passes through this point here. So therefore the equation of this line is y is equal to minus 1, right? So when we have a horizontal line, the equation is always y equal to something, right? Now, I want to go back to something here. Back to my Cartesian plane. Now, in my Cartesian plane, we have, this is what we call my x-axis, right? This is always called my x-axis. Now, the equation for my x-axis is always the line y equal to 0, right? That's a concept that you all need to know. My x-axis is also called the line y is equal to 0, right? On the vertical axis, that is my y-axis, this line is called x is equal to 0, right? It's an easy way to remember. If it's the x-axis, then it's going to be the opposite then. We're looking at y equal to 0, right? So my x-axis is the line y equal to 0. My y-axis is the line x equal to 0. I need you all to remember that, right? I keep repeating this over and over in class. You all should know what this is. Now, let's go back to something here. So I showed you a horizontal line, I showed you a vertical line. Now, let's look at something here. So in this question here, the question is, draw the graph f of x is equal to 2x plus 5. Now, the last two sessions in class, we were talking about functions, right? And typically, we represent a function by saying f of x is equal to something. So in this case here, we have a function, and the function f of x is equal to 2x plus 5, right? Now, another way we could have written this is draw the graph y is equal to 2x plus 5. So in the exam, you could see they can ask draw the graph f of x equal to x plus 5, or they can say draw the graph y is equal to 2x plus 5. It is the same thing, okay? Now, how do we do that? In order to draw any straight line, all you really need is 2 points, right? All you need is 2 points to draw a straight line, but what you should try to do is try to use 3 points, just in case you make a mistake, right? So here's what we need to do. We need to choose some x values and substitute it into the function, okay? So let's do something here. So let's try with, let's say, let's find f of, let's say, minus 5. All right, you can choose any value you want. So let's choose f of minus 5. So this will be 2 multiplied by minus 5 plus 5, which is equal to 2 by minus 5 gives me minus 10 plus 5, which is equal to minus 5, right? So minus 10 plus 5 is minus 5. Now, here's what you need to do. You are going to plot the point minus 5, right? So the point that I'm going to plot is minus 5, minus 5, right? This first minus 5 refers to this one, and the second minus 5 refers to this one. So I go to my graph and I try to find the point minus 5, minus 5. So if I come down here, the point minus 5, minus 5 is actually this point here, right? That's the point minus 5, minus 5. The next thing we need to do, we need to choose another point. I'm going to choose 0 as my x value. Now I keep repeating, you can use any value you want. So 2 multiplied by 0 plus 5, which will give me 0 plus 5, which is equal to 5. So therefore, the point that I'm going to plot now is going to be 0, 5. The 0 is from this here, the value of x that I substituted, and this here is my y value. So the point 0, 5 is going to be this point here, right? Now, I want you all to work out something for me. I want you all to work out, find f of, let's say, minus 2. I want you to work out f of minus 2 for me, right? Let me see what you all get for that. F of minus 2. Okay, so seeing different answers here. See 1, I see somebody get 9. Now f of minus 2, all we need to do, we're going to substitute, right, into the same equation here, which is 2 multiplied by minus 2 plus 5. 2 multiplied by minus 2 gives me minus 4 plus 5, which gives me 1. Right? So you should get 1. So therefore the point that I'm going to plot is going to be minus 2, 1. Alright? So I'm using 3 points here, three coordinates in order to try to plot this graph, right? So this value here is minus 2, 1, which is this. So I have 3 coordinates. So what I want to do now, I want to draw a straight line, right? So what I'm going to do, give me a second. Right? So this is what my graph is going to look like. This is what my function is going to look like. So therefore my function, right, in this case here, the function is f of x is equal to 2x plus 5, right? So notice what I did. When you have to plot a linear graph, we can either just use 2 coordinates if we want, but to be safe, what I typically tell my students to do is to choose 3 points. So what you're going to do, you're going to substitute some x values into my equation, right? So you can get some coordinates that you're able to plot. So the first coordinate that we got was minus 5, minus 5. The second coordinate that we got was 0, 5. And the third coordinate that we got was minus 2, 1. I plotted each of those points and I drew a line through those points. So that is how we draw a linear function, right? Let's try an next one. Suppose we want to plot, so they want us to draw the function minus 4 plus 2, right? So it's minus 4x plus 2, sorry, right? Let's see. Let's try the point. I want you all, this is what I want you all to do for me. I want you all to work out I want you to work out f of minus 2 for me. I want you to work out f of 0. And I want you to work out f of 3 for me. Alright, I want you to work out these 3 things for me. And we're going to use that to plot the graph. Alright, so I'm seeing some students get some answers. Seeing minus 210. Alright, so I'll just give you a few minutes to work that out. All we're doing is substituting. That's all we're doing. Let's take a look at some of these answers here. So I see Sharice has gotten all 3 coordinates already. Alright, so let's do the substitution. So all we're doing is substituting values into this function here, right? So this is going to be minus 4 multiplied by minus 2 plus 2, right? So minus 4 multiplied by minus 2 gives me 8, right? So that is 8 plus 2, which is 10. Right? So the first coordinate is minus 210. The second coordinate now will be, we're going to substitute 0 into this. So minus 4 by 0 plus 2. Minus 4 multiplied by 0 gives me 0. And 0 plus 2 gives me 2. And the last one, it's minus 4 multiplied by 3 plus 2. Minus 4 multiplied by 3 is minus 12. Minus 12 plus 2 is equal to minus 10. Right? So let me get a bigger graph here because this is not going to fit. Right? Hold on a sec. Yes. Alright, so based on the substitutions that we did, the first coordinate is going to be minus 2, 10. Right? So my first coordinate is minus 2, 10. My second coordinate is going to be 0, 2. So my next coordinate is 0, 2. And my next coordinate is going to be 3 minus 10. Alright, so 3 minus 10. Now, let's plot that on the graph now. So the first coordinate, minus 2, 10. Minus 2, 10 is here. This is minus 2, 10 up here. Alright? The next, so that's this point we plotted. The next point is 0, 2. So that's here. 0, 2 is this point here. And my next point is 3 minus 10. So 3 minus 10 is actually somewhere here. Right? So what we need to do now, we need to draw a straight line passing through those points. So graph is going to look something like this. Let's make it a little thicker. I'll just change the color. Alright, so this is what my graph is going to look like. This is what my function, remember the question was to draw a function, right? So this function, f of x, is equal to minus 4x plus 2, right? So I've shown you two different examples of how we draw a linear function. Essentially what we are doing, we are substituting x values into the function, and from that we can get coordinates which we can plot. In order to draw a straight line, all you need are 2 coordinates. But just for safety reasons, please do it for find 3 coordinates, okay? Just in case you make a mistake. Now, coming on to something important here now. We have something called my X-Intercept and my Y-Intercept, right? Now my X-Intercept is where do I cut my X-axis? That's what that means. My X-Intercept is where do I cut my X-axis. My Y-Intercept is where do I cut my Y-axis. Right? So those are 2 terms that you need to know. Something called my X-Intercept and my Y-Intercept. Right? Now, from a graph, once they give us a graph, I can figure out what my X-Intercept is and what my Y-Intercept is. So we have a graph here, right? So this here is my Y-axis. This is my Y-axis. This here is my X-axis, right? Now graphically I can figure out what my X-intercept is and what my Y-intercept is. So some of you might know this, so I'm asking you, what is my Y-intercept? That's the first thing I want to know. What is my Y-intercept? So what is my y-intercept? So Isaac, you're gonna have to review the video, right? Daryl got 4, so I'm seeing people get 4, right, as a y-intercept. But here's the thing: if in the exam somebody asks you what is the y-intercept, they're gonna ask you for a coordinate. The y-intercept is a coordinate, right? So my y-intercept is here. This is where I'm cutting my y-axis, right? Because this here is my y-axis. So this is the point here that we are cutting my y-axis. Now, my y-axis has to be given as a coordinate. Sorry, my y-intercept has to be given as a coordinate. So the y-intercept is written as 0, 4, right? So that is what my y-intercept is. Now, what I want to know now is what is my x-intercept? What is my x-intercept? So I'm seeing a little confusion with the x-intercept, right? Now my x-intercept, right, from the graph, here's where my x-intercept is. My x-intercept is this point here. So you need to give that as a coordinate, right? So we always give our x value first when we are stating a coordinate. So in this case, it is -2 and the y value is 0, right? Now, let's erase some of these things here. Alright, so for the CSEC exam, you could be asked to find the x-intercept and the y-intercept directly from the graph. So if they give you a graph, all you are doing is reading off a coordinate. That's all you're doing, right? However, if they give us an equation of the straight line, which in this case is this here, y is equal to 2x plus 4, we can use that information in order to determine what the x-intercept is and what the y-intercept is. So let me show you how we do this. So the first thing, we want to find my x-intercept. Alright, now the x-intercept is where we are cutting my x-axis, right? Now remember a few minutes ago I told you all that my x-axis is also the line y is equal to 0. Now this is where this comes into play. So at the x-intercept, y is equal to 0. So we're going to say when y is equal to 0, right? This is my equation here. When y is equal to 0, what is going to happen is 0 is equal to 2x plus 4, right? Now this is a simple equation we're going to have to solve now. So if we put the 2x on this side, it becomes minus 2x is equal to 4, and therefore x is equal to 4 divided by minus 2, and therefore x is equal to minus 2. So now my x-intercept is simply whatever my x value is, which is this, minus 2. And my y value, we know at the x-intercept, my y value is equal to 0. So notice something. Notice we have the same answer. This answer is the same as one we just read it off from the graph, right? So my x-intercept is found by letting y equal to 0. Okay? Now, you all need to be able to calculate the y-intercept as well. Now, in the case of the y-intercept, so the y-intercept, right? For the y-intercept, we have to say when x equal to 0, because my y-axis is also the line x is equal to 0, right? So when x equal to 0, what we're going to say is y is equal to 2 multiplied by 0 plus 4. So therefore y, 2 multiplied by 0 is 0, plus 4 is 4. So therefore my y-intercept is going to be 0, 4. So notice we got the same answer again. So this is just two different ways of working the same question. If they give us a graph, we can determine what the x-intercept is and we can determine what the y-intercept is. If they give us an equation, then we're going to have to use the fact that my x-axis is the line y equal to 0, and we're going to have to make use of the fact that my y-axis is the line x equal to 0. All right? So in both instances, we got the same answers, right? Because look, this is my x-intercept here. We got minus 2, 0, and we also got minus 2, 0 from the graph. My y-intercept is 0, 4, and we got the same thing here directly from the graph. All right? So now, let's look at this graph here. I want you all to tell me what is my x-intercept. Just by looking at the graph, I want to know what is the x-intercept and what is the y-intercept, right, from this graph. So I'm seeing Dirella saying x-intercept is 2, 0. And the y-intercept, Giovanni is saying y-intercept is 0, 6. All right? Now, let's take a look at the graph. So, my x-intercept is where I'm cutting my x-axis. Remember, my x-axis is here. This is my x-axis. So I'm cutting the x-axis at this point here. Right? That's where the straight line is cutting the x-axis. So that point has to be given as a coordinate. We write the x coordinate first, so it's going to be 2, 0. Right? So 2, 0 is correct for those who said that. For my y-intercept now, my y-intercept is this point here. That's this point. Alright, and this is my y-axis. So my y-intercept here has to be given as a coordinate again. So this is going to be 0, 6. Right? So my y-intercept is the point 0, 6. Now, that's one way we can determine what my x-intercept is and what my y-intercept is. We can determine that directly from the graph. However, sometimes in the exam, they give you the equation. So in this case, the equation of this straight line here is y equal 3x plus 6, right? That's the equation of the line. Now, if we want to determine let's start with the x-intercept. So we want to get the x-intercept. Right? So if you want to get the x-intercept, we want to find out where does the graph cut my x-axis. We are using the fact that my x-axis is also the line y equal to 0. Right? So to determine this, what we're going to say at the x-intercept, so we're going to say when y equal to 0, right? I'm going back to my equation. My equation is going to become 0 is equal to minus 3x plus 6. If I carry the minus 3x to the left hand side, I'm going to get 3x is equal to 6, and therefore x is equal to 6 over 3. Therefore x is equal to 2. So therefore my x-intercept is going to be, I'm going to write the x value first, which is 2, and my y value, which is 0. And if you look at the graph, that's exactly what we got, right? So this is just another way to work out what the x-intercept is. Similarly, we can work out what my y-intercept is. So my y-intercept, right? We're going to make, for the y-intercept, we know that the y-axis is also the line x is equal to 0. So we're going to say when x equal to 0, right? We're going to put that 0 into my equation. My equation is going to become y is equal to minus 3 multiplied by 0 plus 6. So therefore y is equal to minus 3 multiplied by 0 is 0, and plus 6 we're going to get 6. So therefore my coordinates for my y-intercept will be 0, 6, which is exactly what we got from the graph as well, right? Alright, so those are two things we just covered there. We covered how to find the x and the y-intercepts using a graph, and also using or by calculating it, right? Those are two things you need to know for the CSEC maths exam. Now, what are we going on to? Right. So this is another important concept that we need to understand, and that is how or what is the equation of a straight line. Now, I'm telling you, when I did this a long time ago, I had some problems trying to understand this, right? I don't know if it's because the math teacher was trying to teach us this in Form 2, I don't know, all right? But it was a challenge. So just follow me step by step and you'll get this. Now, the equation of any straight line is given of the form y is equal to mx plus c, right? So the equation of any straight line will be of the form y is equal to mx plus c, right? Now, here's what you need to know. There are two constants in this equation that are important to us, and that is this one here, this m. That m is what we call the gradient of a line, right? If you never heard the word gradient, it's simply the slope of the line. It measures how steep the line is, right? The next constant in this equation is this c here. This c is what we call my y-intercept, right? So my c, or the constant here, is called my y-intercept. So first thing you need to know, every straight line has an equation of the form y equal to mx plus c. The m represents my gradient and the c represents my y-intercept. So if I give you an equation like this, y is equal to 2x plus 1, right? Which is this graph that I have on the right hand side here. Can somebody tell me what is the gradient of this line? So I'm seeing some different answers for the gradient. So if I have an equation y equal 2x plus 1, I just told you all that all equations for a straight line, they have the form y equal mx plus c. Now, if m is the gradient, m is the number that's just in front of the x. So my gradient in this case here is simply 2, right? So m is equal to 2, or my gradient is equal to 2, right? And if I were to ask you what is the y-intercept, what will you tell me? What is my y-intercept? Alright, hold on one second. Just to avoid some confusion here, let me just change this 1, let me just change it to 2. Sorry, 3, right? Because I realize some of y'all will get a little confused here. So the equation is y equal 2x plus 3, right? I want it to be similar to this, right? Sorry about that. So my y-intercept, because I saw some of you all saying 1, right? But I know what you're trying to say. Right? Sorry, I confused some of you all there. So I made a little typo there. So it's right, y equal 2x plus 3, right? So my y-intercept, so you all are saying the correct thing. Well, the y-intercept is this figure here, right? But I must give my y-intercept as a coordinate, which is 0, 3, right? So that is what my y-intercept is. And you can see that from the graph as well. My y-intercept is this point here. That's this point, right? Now, give me a second. Let me just get a blank page here. Now, let me just. So I'm giving you an equation. This equation is y is equal to 5x plus 2. I want somebody to tell me what is the gradient. What is my gradient? The gradient is just one number. And I want to know what is my y-intercept. Right? So my equation is y equal 5x plus 2. What is my gradient and what is my y-intercept? Right, so I'm seeing somebody saying 5 already. Sharice is saying 5. Darrell also saying 5. Alright, so my gradient is simply this number here. My gradient is the coefficient of the x. So my gradient is simply equal to 5. Alright, now my y-intercept has to be given as a coordinate, and the y-intercept, we're going to look at this value here. So my y-intercept is 0, 2. Alright. Give you an x1, y equal to minus 5x. Actually no, sorry, let me just change this, not 5x, I'll give you something else. Let's say minus 2x plus 1. I want to know what my gradient is and what is my y-intercept. So I have y equal minus 2x plus 1. What is my gradient and what is my y-intercept? Yes, Sharice, once it's a y-intercept, the first coordinate will always be a 0. Alright, you all smart too bad. Seeing everybody saying gradient of minus 2. Okay. So the gradient in this case is this value here, which is minus 2. So my gradient is minus 2 and my y-intercept is 0, 1. That's great. You all kind of understand what's going on here. So let's make things a little more interesting. Let's say we have something like this. Y is equal to 2 plus 4x. I want to know what is my gradient and what is my y-intercept. Alright, so for some of you all who might be seeing your screen blur, you might have to refresh your page because I'm streaming in HD here. Alright, could be your internet connection. Alright, so you all seem to understand this very well, right? Nobody fell for the trick. So my gradient is always the coefficient of x. That's this figure here. So my gradient is 4, right? Now there are some students who are going to look at this and they're going to say, oh, the gradient is 2. But the gradient is actually 4. And my y-intercept has to do with this value here. So my y-intercept is 0, 2. Right? Now, we get our next blank page here, right? All right, so let's make things a little more interesting, right? So I want you all to always remember that all equations of a straight line are of the form y equal to mx plus c, right? All of them are like that, right? Now, let's say I have an equation like this. 2y is equal to 6x minus 4, right? That's my equation of my straight line. 2y is equal to 6x minus 4. I want to know what is my gradient and what is my y-intercept. What is my gradient and what is my y-intercept? Let's see if you get this one. Alright, so I'm seeing some people saying gradient is 6, some people saying it's 3. Alright, so some of you all fell for it, right? CXC will deliberately give you a question like this, and some of you all fell for it. The equation of a straight line is always in the form y equal mx plus c. Look at this equation here. This equation is not in the form y equal mx plus c. And why? Because we have a 2 here. We have a 2 here. So this equation is not in the form y equal mx plus c. So we have to do something with this first. So 2y is equal to 6x minus 4, right? The thing is, we need to write the equation in the form y equal mx plus c. In order to do that, what we should do is divide by 2, divide every single term by 2. So therefore, this becomes 2y over 2, which is equal to 6x over 2 minus 4 over 2. So this 2 will cancel with this. This 2 will go into this 3 times. So this becomes y equal to 3x. This 2 goes into this 4 2 times minus 2. So therefore, my gradient is now 3. So my gradient is 3. And my y-intercept is minus 2. So that coordinate will be 0 minus 2. Alright, so my gradient is 3 and my y-intercept is 0 minus 2. Alright, so don't worry, Shirish, that's no big thing, right? I deliberately asked that question to make sure you all understand how to do a question like this, right? So that's no big deal. Let me give you an next one. You won't make the mistake now though. Alright, so I'll give you an next equation here. Let's say I have, so again, just to remind you, the equation of a straight line is in the form y equal mx plus c, right? I'm going to give you an equation here, and the equation is this. 2y minus 6x is equal to, let's say, let's say 4, right? So I have an equation here. I am telling you it represents a straight line. 2y minus 6x equals 4. I want to know what is my gradient. My gradient is equal to something, and my y-intercept. I want to know what my y-intercept is. Let's make it so it's a little more interesting now. Let me see what you all do. Alright, so I'll wait till I get a few more answers. I'll see somebody said the gradient is 3 and the y-intercept is 2. I'll give you all a minute. see if I got more answers. Alright, so I'm seeing Daryl saying is not him. Okay, so I'm not sure what's up with that. Yeah, sure. So looking at the working that you did there. 6x. All right, let me work it, right? I see some of y'all working it, right? So the first thing, we need to write the equation in the form y equal mx plus c. So we're gonna start off with 2y is equal to, let's start over fresh here. Right, so 2y minus 6x is equal to 4, right? So we want the equation in the form y equal mx plus c. So what we need to do, we need to make sure we have y on the left hand side alone. So this is 2y is equal to, I'm going to take the minus 6 and carry it across here, but I'm going to write it first. So I'm going to do this, 6x plus 4, right? The next thing is, I need to get rid of that 2. In order to get rid of that 2, I'm going to divide every single thing by 2. So 2y divided by 2, I'm going to get y. 6x divided by 2, I'm going to get 3x. And 4 divided by 2, I'm going to get 2. So now, my gradient is simply this number here, right? Which is 3. And my y-intercept now is determined by this value here. So my y-intercept is actually 0, 2. Alright, so I'm going to give you all one more, right, to make sure you all understand how to do this. Because I know you all really trying. But let's see. Let's say we have, I'm going to remind you again, so it must be in the form y equal mx plus c. It must be in this form. So my equation is, let's say 3y plus 6 is equal to 9. Right? So this is my equation. I want to know what is the gradient and what is my y-intercept. Yeah, Daryl, what is the question? Alright, so I'm seeing some answers coming in again. Let's see. So the first thing I need to do, I need to take this equation and write it in the form y equal mx plus c, right? So 3y plus 6 equal to 9x. Alright, so you can write 3y is equal to 9x. This is 9x minus 6. We divide every term by 3 because you want to get rid of this 3 on the left hand side. So this becomes y equal to 3x minus 2. Right? So therefore my gradient in this case is simply this number here, which is the 3. So my gradient is 3 and my y-intercept is minus 2. So therefore my y-intercept, I'm going to write it as 0 minus 2. Alright, so I saw a good bit of you all had that. Great. So we have this clean. Now, one second before we talk about this. Alright, so I just showed you how to determine the gradient and the y-intercept from the equation, right? So what you all need to know, you all need to be able to determine the gradient of a line given 2 points, right? But so gradient, we know we use the symbol m to represent gradient, right? Now, just by looking at a graph, you should be able to tell if the gradient of a line is positive, if the gradient is 0, or if the gradient is negative, just by looking at the graph, right? So if I draw a graph for you, you should be able to just look at it and tell me if it has a positive gradient, 0 gradient, or a negative gradient. Now, any line that is sloping this way has a positive gradient, right? So it has a positive gradient. Any line that is sloping this way has a positive gradient. If the line is looking more like this, then it has a steeper positive gradient. So this is a steeper positive gradient. All right. Now, if we have a horizontal line, a line that looks like this, the gradient of this line is 0. So the gradient is equal to 0. Right? So I'll show you what a positive gradient looks like. Right? So the positive gradient is on the left hand side. A gradient of 0 is simply a horizontal line. If I have a line that is sloping this way, then the gradient is negative, right? You all following me? So just by looking at the graph, I can determine if m is going to be positive, negative, or 0, right? So look at this. Let me go back to our graph that we did previously. So this is our graph that we did previously here. If we look at the equation of the line, it was y equal 2x plus 3. Now, the gradient of this line is 2, which is positive. So you notice how the line is sloping, right? But if I look at a graph like, let's say this one here, the equation of this line is y equal minus 3x minus 4. So the gradient in this case was minus 3. So notice how the graph is sloping. So just by looking at a graph, you can tell me if a graph has a negative gradient or a positive gradient or 0 gradient, right? Now, let me get something else here. Just give me a sec, right? One sec, guys. Give me a sec. Just... all right, so here it is. Now, this is one of those things that you all have to learn off, right? The gradient of a line, which is what we call an M all the time, is equal to, there's a formula to work out gradient, right? Now, here's how we're using this formula. I have a line segment here, and the line segment is joined by using the points A and by using the points B, right? In the exam, according to how CSEC sets the exam, they can give you a graph like this, and they can come and they can ask you, find the gradient of this line for me, right? Now, let me show you how we're going to use this equation in order to determine my gradient. Now, I want you all to tell me what are the coordinates of the point A for me, please. What are the coordinates of the point A? Alright, so I'm seeing some answers there. Alright, now you all need to be careful when you're given your coordinates, right? So I'm seeing most people saying 2, 4, and somebody saying 4, 2. Alright, remember when you're given a coordinate, you must always give your x coordinate first. So the point A, if we look at it carefully, right, the point A here is actually 2, 4. Alright, so the coordinates of the point A is 2, 4. I want you all to give me the coordinates of the point B. Alright, so I'm seeing some answers like 612. Let's see, is it really 612? Yes, it is really 612, so it's 612, right? Now, here's how we're going to find the gradient. You all need to learn up this formula, by the way, which is y2 minus y1 divided by x2 minus x1, right? This formula is not given on the formula sheet for the maths exam. Now, this might seem trivial, but I always tell my students to do this in order not to confuse themselves. So here's what you need to do. You need to decide either A is going to be my 1's point and B is going to be my 2's. Let me just explain what that means. So let's say we are looking at the point A. The point A is going to have an x1 and it's going to have a y1. Now, you see what I do in here? This is what I actually do sometimes, right? You need to label it. The point B, we're going to label that as x2, y2, right? Because each of the points A and B, they have an x coordinate and a y coordinate. So, because I've labeled them, I know what is x1, I know what is x2. I know what is y1, and I know what is y2, right? So my gradient M, so M is equal to y2, which in this case is 12, that's this value here. So y2 is 12 minus my y1, which is 4. So it's 12 minus 4 divided by my x2, which is this value here, which is 6. So it's 6 minus my x1 value, which is this value here, which is 2. So this will be 12 minus 4 will give me 8 divided by 6 minus 2 gives me 4, and therefore 8 divided by 4 gives me 2. So the gradient of this line segment here is actually equal to 2. Everybody following me here? You need to do this step by step. This is an exam question that it'll come like this. They'll give you a graph and they will come and they will ask you, what is the gradient of this line? Yes, Clark, coordinates must be given in brackets all the time. So the gradient is 2, right? See some of you all doing it there already. Now, let me give you one to do. Alright, so I want you all to try this one. I want you to find the gradient of this line segment AB for me. Right? I'll give you 2 minutes. What is the gradient M? Right? So I'm going to write down what the formula is. We know the formula is y2 minus y1 over x2 minus x1. Right? Alright, let me see if we have some answers. Alright, so I'm seeing some people getting 2.5 or 5 over 2. Let's see. So here's what we're going to do. First thing we need to do, we need to write down the coordinates of A and B, right? So the point A, or the coordinates of A, are 2, 1, right? That's the first thing we need to do. In the exam, when they give you a graph, you need to determine what the coordinates are first of all. Point B is actually 4, 6. That's the point B. So my gradient is equal to, remember what I told you all, you need to label what x1 and y1. So label this as x1, y1. Why did I put y2? So this is x1, y1, and this here is x2, y2. So therefore, once I've identified what x1, y1 is, what x2, y2, what they are, then all I need to do is to substitute it into the formula. So it'll be 6 minus 1 over 4 minus 2, right? Which is equal to 5 over 2. Now, I saw some of you all put 2.5. There's nothing wrong with that, right? But you see, when you're working in gradients, it is okay to leave your answers a fraction, right? Because it'll come down to something else I'm going to teach maybe next week, right? But what you could do when you find a gradient, it's okay to leave it as a fraction, right? So 5 over 2, if you get that, you can stop right there. That's the answer. That's fine. If you put 2.5, that's also okay. You'll get the mark. But I'll explain in the next class why we need to, or we should leave it as 5 over 2, right? All right, cool. So the answer is 5 over 2. Now, having a question like that is pretty simple enough. This is where students have issues, right? I'm going to give you one here now. So, just give me a sec. Alright, so this is my, now let me just make sure you all understand that in the exam, the question is going to be like this, right? The question is going to state something like find the gradient of the line segment AB, right? So that's what the question is going to come. It's going to say find the gradient of the line segment AB. I want you all to try that one for me, right? So all of them, we're going to start off by writing what the formula is, which is y2 minus y1 over x2 minus x1, right? At the end of this formula should stick in your head, please, right? So I want to find the gradient of this line segment AB. It's a different graph I've given you here. Take your time. So one might be a little trickier. Alright, so Shirisa is saying getting negative 1/5 to your accent, right? You're on the right track. I'm not sure if that's the correct answers yet. Didn't work it out. Kevroy is saying gradient is 3/1. Now, if you all were here at the beginning, right, you all would have realized I said if I give you a graph, you should be able to tell me just by looking at the graph if the gradient is positive, negative, or zero, right? So this graph is sloping a particular way. So that tells me if the gradient is going to be positive, negative, or zero, right? I'll wait to get some more answers before I work it. Some people saying -3/4. Sharice, double check it. Double check it. Yes, Kevroy, it should be negative because of how the graph is sloping, right? Mario is saying, so how we do that, and CXC people say it's only paper 1. This is my Form 4 class, right? I'm preparing them for the May 2021 exam, right? This is just a free preview you all are getting, right? So I'm preparing them for the full exam. Those people writing in 2020, chances are they will only get a multiple choice paper, which may be very different to what the papers they are accustomed to seeing, right? Alright, so I'm seeing answers like -3/5. So you all get in there. Let's take a look at it. You have to be very careful with your negative signs in this particular one. So first thing, you're going to write what the coordinates of A and B are. That's the first thing you need to do. So B will be 3/1, right? And in the case of A, it's going to be -2/4, right? Next thing we need to do, we need to label what x1 and y1 are and x2 and y2. Now the thing is, you can choose whichever one you want, you just need to be consistent. So I'm going to use B as x1, y1, and I'm going to use A as x2, y2. It does not matter which one you choose, your answer will be the same. So here's what's going on here. So y2 minus y1 will be 4 minus 1 divided by x2, which is -2, minus 3. So this gives me 4 minus 1 is 3, and -2 minus 3 is -5. So therefore the gradient is actually equal to -3/5, right? So some of you all got that. So the answer is actually -3/5. You need to be careful in terms of how you're doing your subtraction, right? Alright, so I know you all got a little trouble with this one here, so let's try the next one. So we want to find find the gradient of the line segment AB, right? I want to find the gradient of the line segment AB. I'll give you a few minutes to work that one out. Alright, Sharice, right? Well, once you understood what the mistake was, great. Joshel minus a half. I'm not sure, I don't think so. I'll check it as now. Is it really? Oh, seeing different answers here. Alright, Cherise. Now we cooking. Not looking right. Alright, Giovanni, yep. Alright, so some of you are making mistakes with the subtraction. So let's look at that. So before we can work out the gradient, we need to figure out what the coordinates of those 2 points are, A and B. So this point here, the point A is actually minus 5, 4, right? We always read out the x value first. And the point B here is minus 1, minus 2. So minus 1, minus 2, right? Next thing we need to do, we need to label what is x1. So this is x1, y1, and I'm going to call this x2, y2, right? Now you all have a choice, right? The calculation may be slightly different, but you should get the same answer in the end. So first thing we do, we need to write down what the gradient is, the formula, y2 minus y1 over x2 minus x1. And in this case here, it's going to be minus 2 minus 4 all over x2, which in this case is minus 1 minus 5, right? Now I deliberately gave you all this particular question because it's one of those where students typically make the mistake, right, in terms of how they do the calculation. So minus 2 minus 4 gives me minus 6 divided by, when you have minus 1 minus 5, right? So let me work that up here. Minus 1 minus 5 that is the same as saying minus 1 plus 5, right? Which is equal to 4, right? So you need to be careful with this particular calculation at the bottom here. So when you work that out, minus 1 minus minus 5, I'm going to get minus 1 plus 5, which is 4. But this fraction here can be reduced. So this will be minus 3 over 2, right? So my gradient is minus 3 over 2, right? So I saw some of y'all got that. So it has to be negative, right? It has to be negative because of how it's sloping, right? So be careful with the signs, and I mean, you must know if your answer is wrong. If you work it on and you get a positive gradient, and you know that the graph is supposed to look like this, and it should have a negative gradient, then something is wrong. All right. Now, let me just double check something with your syllabus here. 1 sec. All right, so the next thing we are supposed to be looking at is finding the equation of a straight line, right? So let's just change this here. So all right. So this is another type of question you can get in the exam. So they can give you something like this. Let's say we have so we know the general form or the general equation of a straight line is of the form y equal mx plus c, right? Now I've drawn a line segment here which is AB, and I want to find the equation of this line segment, right? Now before I can find the equation of this line segment, the first thing I need to do is to find my gradient, right? So all these questions, the first thing we're going to have to do, we're going to have to find the gradient. So the question will be, we'll do it in two parts. Find A, the gradient of AB, and the next thing is find the equation of AB, right? It's a typical exam question. Eh? So the first thing is to find the gradient. All right, so that's part A. I want you all to quickly find the gradient, and then I will work out the equation of the line for you, right? So the first part is the gradient. Work that out for me. Alright, so you all work out the gradient for me, and I'll work the equation of the line for you. So Ciceri's got 3 for the gradient. Joshua got 5/4. Double check that answer, Joshua. Alright. So since I only have 10 minutes again, right, let me just try to help you all here. So for A, the coordinates of A will be 1, -1, and the coordinates of B are 3, 5, right? I need to label what my x1, however you want to label it, right? x1, y1, x2, y2, right? So first part, my gradient m is equal to y2 minus y1 over x2 minus x1. At the end of this, I know you all remember this formula because I've said it so many times. So y2 is -1, so it's -1 minus y1, which is 5, all over x2 minus x1, which is 1 minus 3. So this will give me -1 minus 5 gives me -6 over 1 minus 3 is -2. So the gradient in this case, 6 divided by -2 is 3. Alright? So that is how we work out the gradient. Now, the gradient is the first thing that is required when we need to work out the equation of a line segment. Right? Now, here's what we're going to use. We know that the general equation of a line is y equal mx plus c. But here what? You just work out m. And you just work out m, you got 3 as m. So we can say that y is equal to 3x plus c. So we're almost there already. All we need to do now, we need to figure out what this c is, right? In order to figure out that c, I have an option here. I can use the point A to do that, or I can use the point B, right? Now, I'm going to use the point B because I don't have any negative numbers there to make my life easier. So I'm going to say when x equals 3, y is equal to 5, right? Because that's this coordinate here. The point B is 3, 5. So when x is 3, y is equal to 5. So what I'm going to do now, I'm going to substitute those two values into this equation here. Alright? So therefore 5 is equal to 3 multiplied by x, which is 3, plus c. Right? This 3 here is from this. So therefore 5 is equal to 3 3s are 9 plus c. So therefore I can say that, now what I teach my students, I tell them write it as 9 plus c is equal to 5. Right? Because if 5 is equal to 9 plus c, then 9 plus c is equal to 5. So therefore c is equal to 5 minus 9. Therefore c is equal to -4. Right? So I've just figured out what c is, because the two most important things in order to find the gradient will be what m is, and I just worked out what c is. C is -4. So I'm just going to write this on top here, right? So the answer or the equation of the line will be y is equal to 3x, because I know the gradient was 3, minus 4, because you just worked out what c was. So the equation of that line that we're talking about here is y equal 3x minus 4. Alright? So we covered a good bit of work here, right? We looked at how we plot points on a graph. We looked at how to draw a graph of a straight line, right? We spent a lot of time looking at what the equation of a line is, right? I told you when you have a horizontal line, the equation is y equal to something. If it's a vertical line, the equation is x equal to something. We talked about positive, negative, and zero gradient. I also showed you the formula to find the gradient of a line segment. And the last thing we looked at here was how do we determine the equation of a straight line, right? Obviously we need more practice with this particular one that I just did, because I know some of you all, this could be confusing for some people, right? So in the next class I will be looking at continuing with this and also looking at actual exam questions, right? So I hope you all had a productive session, right? Let's see if anybody have any other questions before I go. All right, so I saw some of you all asking about do simultaneous. Now, remember I said this is my Form 4 class, right? So I'm going through what I'm supposed to be teaching my Form 4 class. For those of you who want additional help, you can go onto YouTube and go to my channel. So you see that question you asked about simultaneous equations. I already have videos concerning those things on my channel, right? I also have solutions to past papers as well. So have a look at my CSEC Maths channel, right? Just do a search, it'll come up, right? So anyway, guys, be safe and see you all next week, right? Take care.